Okay, this is the fourth problem on the energy conservation inquiry. We have a ball that's rolling along the ground at 20 meters per second, and then it's going to start rolling up an incline. And it'll only go up so high, and we want to figure out what's the distance up the incline that it will roll. And so we have the D measured or listed on here on this inclined plane. We also have the height that it'll get to. It'll only go so high because it'll run out of energy. So we start with the conservation of energy here, and down here at the bottom it has all kinetic, and it has two types of kinetic. It has linear kinetic, which is 1/2 mv squared, and it has rotational kinetic, which is 1/2 I butt squared. And that all that kinetic energy, as it goes up the inclined plane, will get turned into all potential energy. So up here at the top at point 2, it'll have mgh amount of energy. So we'll start with this to figure out, derive an equation for this height right here. H is what we want. So we're going to have 1/2 mv squared plus 1/2, and then in for I, this thing actually isn't a ball, it's a disk. And if you remember, the rotational inertia equation for a disk is 1/2 mr squared. So in for I, I'm going to put 1/2 mr squared. And in for angular velocity squared, if you remember, we can put v squared over r squared, because the angular velocity, the rotational velocity of the disk, is related to the linear velocity by r. So we take v divided by r, and we'll have angular velocity. And the reason I want to do that is because now I don't need the radius. I can cancel out radius squared. I can also cancel out, well, let's see, this still equals mgh. I can also cancel out mass out of all of the equations, and I'm going to get 1/2 v squared plus 1/4 v squared. 1/2 v squared plus 1/2 times 1/2 is 1/4 v squared equals gh. And then 1/2 plus 1/4, of course, is 3/4 v squared equals gh. And then the h, then, the height here, should equal 3/4 v squared over g. So the velocity was 20 meters per second, so if I square that, and then I take that times 3, and then I divide that by 4, and then I divide that by 9.81, I get a height here, the h, of about 30.6 meters. This is 30.6 meters. So what is the distance here? Well, we have sine of the angle, sine of 30 equals opposite 30.6 over d. So d would equal 30.6 divided by the sine of 30. But we also know sine of 30 is 1/2. So the height here is always half of this distance right here. So all I'd have to do is take 30.6 times 2, and I would get a displacement here that it goes up the incline of 61.2 meters. That's how high it goes up. So we use conservation of energy to solve for this height right here. And since we have the angle, we can figure out how far up the inclined plane it's going to go. So hope you understand that problem.